So the next topic for the function for today's class is composition of function. So what is composition of function? If I say f is a function from set A to B and g is a function from set B to C, then the composition of the function is called as GOF, GOF. So this is a function from A to C. Means if f is a function from set A to B, g is a function from set B to C, then the composition function is a function from A to C and it is represented by GOF of x, and that is nothing but g of f of x. Okay, so now we'll take one example. Suppose I have given two functions, fx is equal to x plus 2 and gx is equal to 2x. Now we have to find fog x and gof x. So f for g x and g of x, what is that? So if I say fog x means f of g of x, and if I say gof x means g of f of x. So f for gx means f of g of x. Okay, so first one we have to find out this. So this is nothing but f of g of x. So now what is g of x? Gx is given 2x. So we will write, instead of gx, I'll write 2x. So now it is f of 2x. So f of x is equal to x plus 2. So what is f of 2x? Instead of x, I have to substitute 2x. So it is 2x plus 2. Now I have to find this value. This will be nothing but g of f of x. So what is f of x? It is x plus 2. So I'll write x plus 2 here instead of fx. Now g of x plus 2, gx I know it is 2x. What is g of x plus 2? Instead of x, I have to substitute x plus 2. So in place of, so it is 2x. So in place of x, I have to write x plus 2. So it is 2x plus 4. So see, this first value I got 2x plus 2 and this second value I got 2x plus 4. So that means it is clear that these two values will not be equal. Now one more example we will take. Suppose I have I have three sets here. A has 4 elements, 1, 2, 3, 4. B has 3 elements, A, B, C, and C has 4 elements, W, X, Y, and Z. And it is given f is a function from set A to B, g is a function from set B to C. So what will be the value for, we have to find for each element, what we have to find? We have to find this GOF. So and f, see, these three sets are given and the function is also given. F, what is function f? This value is function f is given and function g is given. So now I have to find GOF for each element. So that means for GOF for 1, GOF for 2, 3 and 4 I have to find, because now GOF is a function from A to C. So A to C means with respect to the first element of the first set, I have to find the GOF. So GOF of 1 means g of f of 1. So what is f of 1? We will see here in the function f. F of 1 means what is the image of 1. Okay, so image of 1 is A. So I'll write 1 A here. So now what is GA? Means I need to see the function G. So what is the image of A? It is X. So I will write X here. So basically GOF of 1 is equal to X. So that means I can write GOF, in GOF function I can write 1x, means the image of 1 is x. So we are saying if f is a function from A to B, g is a function from B to C, GOF is a function from A to C, means if 1 is associated with A and A is associated with x, so 1 is associated with x. Like that. Now for GOF of 2, it is g of f of 2. F of 2 means the image of 2 is A, and g of A again I have to see the function g, that is x again. Now GOF of 3 is g of f of 3. The image of 3 is B here. So and the image of B is y here, so it will be y. And GOF of 4 is the image of 4, I need to see the function f, that is C, and the image of C I need to see the function g, that is z, so it is z. So the same way I can write the other ordered pair also. This is for 2 it is coming x, so 2x and then 3y and 4z. So this is how we are going to write GOF function. Now these are some facts about the composition function. So if f and g are 1 to 1, then this function will also be 1 to 1, and if they are onto, then this GOF is also onto function. And composition always hold associative property, but it is not commutative. So commutative, just now we saw in the first example, fog is not equal to GOF. Okay, now next topic is onto function, Stirling number of a second kind. This is to find the number of onto function. So if I have two finite sets A and B, so where M is the number of elements in the set A, means this symbol means it shows the cardinality. So cardinality means the number of elements in set A, and N is the cardinality of set B. So this is the formula. This is the formula for calculating the number of onto function, and it is also called as Stirling number of second kind. So this is a summation from k 0 to n minus 1 power k n minus n c n minus k power m. So if k is equal to 0, here in place of k I have to substitute 0, k equals to 1, 2, 3, like that, and m and n are the basically the cardinalities of the first and second set. So I have to substitute the values here, and we can calculate this value and we can find out the total number of onto function. So if I expand it, so first what we have to do, k is equal to 0, if I put till the minus 1 power 0 and n minus 0 and minus 0 power m. So this value will get, and then the second one, when k equals to 1, here in place of k everywhere I have to put 1, this value I'll get. When then k equals to 2, this value I get, and since it is minus 1 power k, so alternatively plus minus I am going to get. So this is just the expansion of this formula. Now we'll take one simple example. So now A is having 7 elements. So what is M here? 7, and B is having 4 elements. So N is 4 here. So M is equal to 7, the total number of elements in A, and N is equal to 4, it is given the total number of elements in B. So we have to find the number of onto function. So we will just substitute in this formula. So here k equals to 0 to n is equal to 4. So k equals to 0 to 4 minus 1 power k, and in place of n 4 will come 4 minus k power 7, and we have to just expand this. So when k equals to 0, it will be 4 minus k is what? 4 minus 0 power 7, so 4 power 7, and then when k equals to 1, it will be 4 C3 and 3 power 7. When k equals to 2, it is 4C2 2 power 7. When k equals to 3, and k equals to 4, like that we will just, and this is 4C4, and we know how to find the NCR. The formula of NCR is n factorial upon r factorial into n minus r factorial. That way we can find this value, and we have to just calculate, and we are going to get 8400. So these many onto functions from A to B. So if the question is asked, find the number of onto function, so this formula we have to apply. This is also called as Stirling number of a second kind. Then some of the example I'll discuss. Here A is having 4 element A, B, C, T, and B is having 4 elements E, F, G, H, and F is a function from A to B, and this is given. So this is see, basically f of A is equal to E, means the image of A is E, the image of B is E, the image of C is H, the image of D is G, and in terms of ordered pair I can write like this: AE, BE, CH, and DG. So that the meaning is same. The image of A is E, image of B is E. So this is what a relation. Now this is the relation from A to B, because here f of A is equal to, means what is the image of the A, that is E coming here, right? So now this is the function f from set A to B. If in terms of relation I am writing like this. So if I want f inverse, so f inverse, what I will do, I'll just reverse the ordered pair. If it is A, I will write EA, B I will write EB, CH I will write HC, and DG I will write GD. Okay, so now this is f inverse. Now what is domain of f inverse? If I have to find the domain of f, so domain means I am going to write the first element of each ordered pair. Range means I am going to write the second element of each ordered pair. So here domain will be, for f inverse, domain will be E, H, and G. So that is nothing but the range of f, right? And similarly, range of f minus 1 will be the second element of the ordered pair. That is nothing but the domain of f. Okay, and also f inverse, if again for this function, again if I take inverse, these will reverse and I will get back the same function f. So I can write f inverse whole inverse is equal to f only. So f inverse is the relation from b to a. Now if I have to find, so this is with respect to the relation, is it a function also? Now for function we know that we have two conditions. First one is all the elements of the first set should be associated with the second set, and each element of the first set should have unique image in set B. Means if I say element A, so A should have a unique image in B. A cannot have more than one images, but two different elements from the first set can have the same image. Okay. Now if I say this function, this F inverse, so here E and E means both E are having, here E is having image A and image B, so that is not possible. So it's a relation, but it cannot be a function. Okay, now this one, the second example, if A is having 4 elements 1 2 3 4, B is having 4 elements 5 6 7 and 8, and f is a function from A to B, and this function is also defined here. Means the image of 1 is 6, see it is written here, image of 2 is 8, image of image of image of 3 is 5, and image of 4 is 7. So here this in terms of ordered pair it is written. So f inverse means I am going to reverse it. Now is it a function also? So see here, 6 is having image 1, 8 is having 2, 3 is having 5, 7 is having 4. So each elements are having unique image. So that means it's a relation as well as function. So this is all about function topic. Thank you.